An amazing logic building question, 155 min stack. In this problem, what we need to do is we need to define a min stack. As the name suggests, it is something related to stack. Yes, it is related to stack, and in other words we can say that it's an extension of feature of the stack. Like, we know that what stack is. Stack is a data structure in which insertion and deletion are performed from one and only one end, that is top. Like, if you need to insert a new value to the stack, we can only stack it from this way, and if we need to remove an element from the stack, we can only remove this topmost element from the stack. Like, this follows LeetCode. We can understand it with an example. Like, if we have to insert 1 2 3 4 in the stack, let's suppose first we have this stack, an empty stack. First 1 will be inserted, then 2 will be inserted, then 3 will be inserted, then 4 will be inserted. But when we need to delete, when we need to remove elements, the last inserted element will be removed first, last in first out. First 4 will be removed, then 3, then 2, then 1. This will be the order followed when we need to pop out the elements. A basic stack contains few major functions. Like, it has a function push, by which a value is inserted into the stack. Another is the pop function, through which a value is popped out from the stack. And there is another function empty, which will only return boolean value to check to present whether the stack is empty or not. What we need to do, another function is top, which return the topmost element. Like, if at this point we will be asked get top, we will return 4. And the extension of this basic stack structure for this question is another function, get min. This function should return the minimum value present in the stack. This can be applied in multiple ways, but we are asked to perform all these functions in a bigger one-time complexity, that is, in a constant time. We are not asked to apply this using loops or by popping out all the elements to find the minimum element, then pushing back all the element back. That's not the approach we are asked. We are asked to implement this getMin function along with this function in a constant time. How are we going to implement it? To implement it, there are multiple ways, but two prominent ways comes to my mind. The first is we can have the stack. We can have our stack containing the value part and the minimum value up till that part of the stack. Like, we can understand it with this example. Let's suppose the elements 1 0 3 5 and 6. These are 5 elements we are supposed to insert. First, when our element is 1, obviously the minimum value present is 1 because the stack was empty earlier. When 0 came, 0 is found to be less than 1, so at this point the minimum value will be 0. For 3, the minimum value will be 0 because it is greater than 0, our previous minimum value. Same goes with this way. So at this point, if we ask getMin, we will return 0. At any point we will be asked our minimum value, we will simply return the second value. This could be implemented using a stack having pair of int comma int. So when the time came when we have popped out all these elements, and if we asked again to give our minimum value for this part of the stack, we can simply return our second value of the top pair. This is the one approach, but the problem with this approach is it requires 2n space complexity. though it's a good approach, making it possible to return to apply all these functions in a constant time, but there is an optimization for this approach. Let's discuss that. For that, what we're gonna do is we will be having an extra min val variable which will be having our minimum value for that part of the stack. But implementing this is not as straight as it sounds. We can let's take another example, 2, 3, 0, 5 and 7. First we have inserted 2, then we have inserted 3, then we have inserted 0, then we have inserted 5, and then we have inserted 7. When we were at this point, if our minimum value would be asked, we would have written 2, no problem. If at this point it would be asked, we would have our minimum value retained and would have returned 2. At this point 0 came, we simply would have written 2, we would have written 0. But the tricky part comes when we have popped out this, when we have popped out 7, no change, when we have popped out 5, no change. But when we have popped out this 0, which was our minimum value for above instances of the stack, but when we have popped out 0, how could we get back this? Because the minimum value, a variable can contain only one value at a time. How we can trace back our previous min value? That's the question, and that's the trickiest part of this approach. But it is not as tricky, but when we understand it, it becomes very simple. To implement this function, let's first define how we're gonna define our push function. But before that, let's structure our program. We will be simply using our normal stack with not int. We will be using long. I'll tell you about why we are using long instead of int. And another variable we are gonna use is long min value, which will be contain the minimum value. So let's first code for our given value long val. Let's suppose this is a value we are given. If I'm writing it a pseudo code, so just ignore if there is any syntax error. So if there would be if our stack is empty, I'm just writing it in a pseudo manner. If our stack is empty, what we gonna do? We gonna simply insert it, push the element, and then we will update our min value to that value, because that was the only value we are left with. So this was the if part. But if, let's see, we have updated to, if 3 comes and 3 is greater than 2, we don't need to update min value for that. So if our value is greater than or equal to the top value, for this instance 2 was top value, 3 was coming, not have inserted yet. So if the value is greater than top value, we will simply push that element with no change. But if the value is less than our stack top, like in this case 0 is less than our 2, we won't be comparing it with 2. It would be better to compare it with minimum value. So 3 is greater than our minimum value, that was 2, so we have inserted it. But here comes 0, so 0 is less than our minimum value, so obviously we need to update it. But we gonna update in such a way that when we return back, when we were returning back in any instance, when we have to push, when we have to pop out all the element, we could get back our previous value. We are using it in this way. For that, we don't just insert the value we are given. We will code it in a certain manner so that our previous value could be found using our new value. For that, we are using another variable. a temporary kind of a variable, new val, which will be inserted in place of a val, and we were coding it in this way: to val minus min val. This is a very useful expression, and instead of inserting value, we will push our new val. And as the val is found to be less than minimum val, so we will update our min val to val. This way we can push it. The part comes when we need to pop out our element. When we have to pop out elements, see, at this point, when we have to pop out 7, since 7 was greater than minimum value, no changes, we can easily pop out that. The tricky part comes when this minimum value itself has to be popped out. For that, we can consider it this way: like if our top value is less than our minimum value, or we can say equal to our minimum value, what we're gonna do is we get back our minimum value by reversing this 2 into min val minus stack top value. Why we are doing this? Like, see, val has become our minimum val is what? Our val, which we have updated this way. So we are just rewriting this. New value is taking place of our stack top. Min value, we need to find again our updated value, and 2 into val, this was our min value updated, so we are writing it this way, and we get our minimum value back. Let's consider it this way in an example, like when 0 was to be popped out. Since 0 is less than equal to our minimum value, what we're gonna do is update our minimum value. Minimum value would be is equals to 2 into our minimum value was 0 minus stack top. What's there in the top? When we are doing this min val new value is not same as val, so it won't be inserted as 0. It would be coded in some different way. Like what we have done is new value, when 0 came, what we're gonna do is we will multiply 2 into val minus our minimum value minus 2. So we will insert minus 2 instead of 0. So when coming back, 0 having our minimum value, we will get back our minimum in this way. Like minimum value, our previous minimum value is found to be 2 into min val was what? 0 minus stack top. What was there in stack top? 2. So we will get this way, we get our 2 as minimum value, and later part is very easy, we can simply implement that. Like if we have to get min, it will simply return our min value, and the top value will return our top value. Top value would be what? If top value is found to be minimum value, then we will return less than minimum value. Like minus 2 is less than 0, we will return 0. But if 5 is greater than our 0, so we will return 5 in this way. The code part is presented in the description. Go check out.